Today we're going to be talking about how to find the least common multiple. That's what LCM stands for, least common multiple. One way to do it is to simply count by the multiples. So if I was to do my multiples for 3, it's just multiplying 3 by another integer. So we'll start with doing 3 times 1, which is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. Running out of room. 3 times 9 is 27. You may also recognize another pattern. You're counting by 3s. If you were to find the multiples of 8, you would do the same thing. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 5 is 40. I'm going to stop there and explain what we're doing. So the goal of finding the least common multiple, least meaning the lowest number, the smallest number, is as soon as you see a match in the two numbers, that's your least common multiple. So I noticed that when I was completing the multiples for 8, it had a 24, and 3 also has a multiple of 24, and that's the first number that they both have in common. So the least common multiple of 3 and 8 is going to be 24. The LCM equals 24. That's one method. Sometimes though, you find yourself counting and counting and counting and counting, and it takes a long time. So I'm going to show you another method. We're still going to do the same problem. What's the least common multiple of 3 and 8? But I'm going to show you another way. So some students prefer to use factor trees. For number 3, the number 3, it's a prime number. So the only thing you can multiply to get to 3 is 1 and 3. So you are actually good to go because it's a prime number. For 8 though, you can multiply two numbers to get 8 other than 1 and 8 itself. So to get to 8, you can do 4 times 2. Now 2 is a prime number because you can only multiply 1 times 2 to get 2. So I'm going to circle that number, but I can break down my 4. I can multiply two numbers to get 4. 2 times 2 is 4. I know that 2 is a prime number, so I'm going to go ahead and circle my 2's. Now that my factor trees are done, there's nothing else that I can break down. This one was already good to go. I'm going to write my prime factorization. Prime factorization is basically every prime number that you have to multiply together to get to that number. So for 3, it was already in its prime factorization. It's just 3. For 8, the prime factorization is 2 times 2 times 2. So I'm going to write that 2 times 2 times 2. Then students will look to see who has the more 3s, 3 or 8. Well, 3 automatically wins. It's the only one that has a 3. And then you'd look again, who has the most 2s? Well, 8's the one with all the 2s, 3 does not have any. So I'm going to go ahead and box these out. So essentially what you're doing is you're multiplying all of these that you boxed. 2, these kind of look like Z's, sorry. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 equals 24. That's exactly what we got using the other method as well.